In this video, we will be able to get the pH of strong acids. The pH of strong acids are very simple to get. Just get the molarity of the strong acid, take the negative log of it, and you will get the pH that way. Very simple. But you have to know first which are the strong acids. And you have to memorize the 7 strong acids. Okay, so the strong acids, if you go down the periodic table, you have FCl, Bri are the halogens. They get bigger. As they get bigger, the distance between the H and the I gets bigger, which means this bond gets very weak bond. If the bond is weak, the H comes off really easily, and the electron stays with the I. If the H plus comes off really easily, it makes it very strong. So HI is very strong, along with HBr, and along with HCl. Okay, HF is very weak acid, and the reason is the distance between the H and the F is very close, making the bond very strong, and the H stays. So do not include HF. The other strong acids are due to the oxygens. So they're oxy acids, H2SO4. The O's pull electron density away from the H again, and the H comes off. H2SO4, HNO3, HClO3, and HClO4. Okay, this is sulfuric acid, nitric acid, chloric acid, and perchloric acid. So by definition, these are strong electrolytes. When you hear that word, electrolytes means they conduct electricity. And the reason why they conduct electricity, because when HCl, one of the strong acids, dissociate 100% of the time, they will become ions, H plus and Cl minus. And if you put a light bulb with electrodes, of course you have to plug it in. The electrons can't go across because there's no connection, but the presence of electrolytes or ions will help carry the charge across and light up the light bulb. That's why all these acids are strong electrolytes, because they produce a lot of ions. So to get the pH of the strong acids, you have to remember that the HCl molarity is the same as the H plus molarity. Okay, and the reason is this. Let me tell you. If you want to get the pH of a 0.1 molar HCl, if this HCl is 0.1 molar, if it's a strong acid, it will dissociate 100% of the time, which means if you have 0.1 molar HCl, you will also have 0.1 molar H plus, and you will have 0.1 molar of Cl minus. Okay, so simply, the molarity of HCl is equal to the molarity of H plus. So this is 0.1, this is also 0.1. The formula for the pH is equal to negative log of the concentration of the H plus. It'll be negative log of 0.1, and that would be 1 times 10 to the negative 1 if you plug that in the calculator. Okay, in terms of significant figures, the pH will be 1. Okay, so in terms of significant figures, 0.1 has 1 significant figure, so you should really put 1 significant figure right there. That has 1 log numbers. The significant figures are after the decimal point. If you haven't watched the videos on pH, significant figures, and H plus and KW, you must watch it before we go on. It will get very confusing if you don't. Okay, here's another example. What's the pH of a 0.04 molar HClO4? Well, yes, that's a strong acid, so you're going to just do pH is equal to negative log of 0.04, which is equal to 1.40 is the pH. Here we have two significant figures, and here we have two significant figures. Pause the video and try this yourself. Okay. An aqueous solution has HNO3, strong acid. pH is 2.34. What is the molarity of the acid? HNO3. Well, the molarity of HNO3 is going to be the same as the molarity of the H+, because HNO3 is one of the top 6 or 7 strong acids that you memorized. Okay, so if the pH is equal to 2.34, then the H+ formula is 10 to the negative pH. So plugging that in will be 10 to the negative 2.34, which is equal to 0.0046. Molarity of the H+, which is the same as the molarity of the acid, which is HNO3. Very easy. And again, this has two significant figures, so you get two significant figures. And that's how you handle strong acids. Very simple. Okay. Now, how do you handle strong bases? Strong bases give OH minus. And if the substance has OH minus in it, they must be able to dissolve. So if I buy LiOH from the store, Li is in the first group, the alkali metals. Since alkali metals are fully soluble, you will get 100% OH minus. Same with NaOH, RbOH, and cesium OH. So these are very strong bases. On group 2, you only pick the bigger, and it gets bigger. I'm sorry, calcium is above there. But these are the big group 2, which means the bond between that and the OH is farther, so the OH comes off. This is Sr+2, so you will need 2 of the OHs. So BaOH2 and CaOH2 are the top strong bases. So please memorize these, 1, 2, all of these. Okay, so any strong bases are the soluble hydroxides, which are group 1 hydroxide and group 2 heavier and bigger earth metal hydroxides, strontium, barium, and calcium. So the reason I have it in this list is it's spelled Serbaka. It sounds like Chewbacca. Okay, again, these substances will dissociate completely. So if you have 0.1 molar of LiOH, you will have 0.1 molar of OH minus. Here's an example. What is the pH of 0.028 molar NaOH? So if you go NaOH becomes completely dissociated, 100% plus OH minus. So if this is 0.028 molar, so this is also 0.028 molar. Okay, which means to get the pH of this, you have to get the pOH first. pOH is equal to negative log of the OH minus, which is negative log of 0.028. That has two sig figs. So my pOH will be 1.55. 2 sig figs. And my pH will be 14 minus 1.55 because pH and pOH equals 14. So it'll be equal to 12.45. Okay, so that's A. So you pause the video and try B. Okay, so the equation for the dissociation of calcium hydroxide, and it is a strong base, so it's 100% dissociated, will be calcium plus 2, plus you're going to get 2 hydroxides, so 2 for 1. Okay, so if this is 0.0011, that means you'll get double this, 0.0022, which means pOH is going to be equal to negative log of 0.0022. which is equal to 2.66, and pH is equal to 14 minus 2.66, which is 11.34. Okay, this has two significant figures. You get two significant figures here.